So in the previous video, we have seen how the Holt trend model works, but that model cannot account for seasonality. So to account for seasonality, of course, there are a few other models, but one of the basic model is the Holt Winters model, and it is actually very well performing in many cases. And this model has two types, multiplicative and additive, and there's not really much difference. It's only in multiplicative we use the functions, we use the equations in multiplicative terms, and in additive model we use the equation in additive terms, and we will see that. So now let's dive in. If you look here, again we represent the main function more or less in a similar way as we were doing in the Holt's trend method, but here, so we have the LT for level, and then we have the TT for trend, and multiplied with H, which is our horizon, and then we multiply this whole part with ST minus 1. Okay, so this is our seasonal component. So this is the new addition in this method, and here mathematical notation is ST minus M minus H. Okay, where M is number of seasonal period and H is number of forecast horizon. Okay, so this is forecast horizon, this is seasonal period. So now again, as we have seen earlier, we will have three different equations for these three terms, for level, for trend, and for the seasonal component. So now first let's have a look into the level equation. So here what we're doing is more or less in same format as before. We have this parameter alpha and we multiply it with the YT divided by ST minus M. So M is the seasonal period. So let's say if our data is monthly, okay, that would mean that our season could go across 12 months, right? So that would mean that here YT, so YT will be divided by ST minus 12. Okay, so if YT is January of 2020, then we have to divide this value by seasonal value of January 2019. Okay, so it's 1 year back. So that's how this seasonal component works. And then plus 1 minus alpha into LT minus 1, the previous level value plus the previous trend value, T minus 1. So now let's have a look into the TT, that is the trend value. So here we have this beta parameter, and here we have LT, so level value of time T minus the previous times level value plus 1 minus beta into previous times trend value. And then we have the equation for the seasonal component. So here what we have is we have another parameter now. So previously we have seen only two parameters, two smoothing parameters. Now we have three parameters, and because of that sometimes it is called triple exponential smoothing model as well. And we call it gamma, and we multiply it with the ratio of YTT, the actual value, divided by the LTT, the level value of the same time period, plus 1 minus gamma into ST minus M. So this refers to actually this point here. So 1 minus gamma should be multiplied with the seasonal value of the last year. Okay, this is for monthly data, and it would vary for quarterly data or weekly data. For weekly data we will use 52 as our M value, so we will go 52 weeks back. Or for quarterly data, so we have 4 quarters, so we will use 4. So now what else we have here? We have some explanation. So normally the YT plus 1 is the forecast value at time T plus 1, and LT is the level value at time T, and then the TT is the trend value at time T, and ST is the seasonal value at time T, and alpha, beta, gamma, these three are smoothing parameters, and this H here is the forecast horizon, and M is the number of seasonal periods. And alpha, beta, gamma, all three of them has to be between 0 and 1. Before we see how it works in Excel, I will actually show only this multiplicative one in Excel, but I will also explain a little bit the additive one before we go to Excel. And both of them are very similar, okay, in formulation. It's only here, instead of this divide, we will use minus. Again, also here we will use minus, and here we will use plus. These are the three things that change in the additive model. So let's have a look. Okay, so now I'm going for additive model, And here you can see that we use plus instead of multiplication term of the seasonal component. We just add it with our L and T. And here you see when we from the LT, then we use minus instead of the division. Okay, and our TT actually remains the same as in the multiplicative model, and our ST. So here you see we are using minus instead of division. Instead of dividing the YT by LT, we are just using minus. So these are the only three differences between the multiplicative and the additive Holt-Winters model. So one logical question is when to use the additive model and when to use the multiplicative model. So the simple answer is that when we have very high fluctuations or variance in our time series, then we will go for the multiplicative model, and if not, then we will go for the additive model. And by fluctuation, I mean that when our time series values gets higher and the probability of variance gets even higher, that's when we actually will be using the multiplicative model. So the variance gets larger when our values gets bigger, So that's when we use the multiplicative model. And normally in shipping industry, it's a very common phenomena. In Bitcoin forecasting, it is also very common. For weather forecast, I would say maybe additive could work fine because there may not be very high fluctuations. So these are just the explanation as we have seen earlier, and all these three parameters has to be between 0 and 1. Now let's have a look how it works in Excel. So now we are starting with the Holt-Winters model. Okay, so Holt-Winters model, and we will need at least 4 columns for Holt-Winters. Okay, we will need at least 4 columns and free smoothing parameters. So the first one we will call it LT, the level one. Okay, and then we will need TT for trend, and then we will need ST for season, and then we will have our forecast that we will call YT plus 1. Okay, and when we are done, we will calculate the error, and then we will use another column for that. Okay, but now let's use these ones and let's see how to get this model working. And also, so here we will use the alpha parameter for LT, the beta parameter for TT, and actually we will need one more parameter for the gamma parameter here for our seasonal component. Okay, so these are the 3 parameters that I will be using. And just to start off, I'm just putting some values here. For instance, let's say I put 0.4 and then 0.3 and then 0.2. So just to start off, I'm putting these values here. We have monthly data, so that means that actually our season, this 12 month is our season, and our next season will start from January of the next year. Okay, so that means we will actually start from this period here, and before we start working on this period, we should actually calculate the season for all these previous periods, and we can use that when forecasting the values for the next period, next season. So first what we will do is, to start off, we will calculate a seasonal index or seasonal values for the first season. Okay. And to do that, we will start with equal to, we will start with the function, and then the way we'll be doing it actually is that we divide our original value of the same level by average of the whole season. Okay, and then we have to fix it. So I'm going to use F4 to fix it. Okay, so this is how we will get a seasonal value, and then we just drag it for all the 12 periods, and I'll make it up to 3 points. Okay, so that's how we have calculated our season, and we can use it to forecast in the future values. So now let's start from January, and let's start from LT. To start off, actually what we will do is we will use the first part of the equation only, YT divided by YT minus M. So to do that, so I'm going to start the equation with YT, so it will be the same level, okay, divided by YT minus M. So that would be January. So T minus M is 12 here because our seasonal period is 12. So it will be the season of last year, of the same period. So that would be January. So I'm going to select this one here. So that would be my value for LT. Just to starting, this is my starting value. Okay, this is not really forecasted because I'm not using the equations. And then to start off with TT, we will again use only the first part of this equation, LT minus 1. So if we start, so how do we get LT? LT is already here, the same level, but we don't have the value of LT minus 1. But we can also kind of estimate that. So minus, to get the LT minus 1, what we can do is we can divide our YT minus 1 with its corresponding seasonal value. And actually the real seasonal value would be the value of December 1995, and which we do not have. So instead what we can do is we can simply use the value of December 1996 to get this value. So we divide this with the value of December 1996. Okay. So that's how we get a estimate. We get an estimate for the trend value. Okay. So these are the values that we got. Awesome. And by now actually we have all the information that we need to put our real equation for the seasonal part of the model. So to do that, I'm going to start with my equation here, and then I'm going to select my gamma parameter and press F4 to fix that. Multiply this with YT, that is here, YT divided by LT, that is here, right? Close my bracket and then plus 1 minus gamma, and then I fix my gamma again. Okay, multiplied with ST minus M. So then it will be the season of January 1996, this value here. So I'm going to press enter now. Okay, so just for you to see, this is my equation. Okay, and this was actually real estimation, and these two were just to start off, and I'm going to put red for them. And as you can see in the equation, we are actually using the T level values to forecast T plus 1. So the T plus 1 would be actually in this level here, okay, not this one. So we are starting here for T plus 1. So to forecast, what I'm going to do is I'm going to start with the function, and then we have the LT plus TT, okay, and I'm not going to use the H now. I'm going to use the H. H is forecast horizon, and I'm going to use it for outsample forecast. And then we close the bracket. We multiply this period with its previous year's corresponding time period seasonal value. That is, so we are in February now, so that would be February last year, right? So and then we press enter, and this is our value. So this is my value for forecast for February 1997, and if I just double click it, I will have all the information placed there, but they are empty because we haven't done much. I can also drag actually this one, so I have the equations placed, yeah, in the right places, but these equations are dependent on this part, so when we will have this calculated, this will come up. So now let's see how to move on. So now we go back to LT, and now what our goal is actually to put the equations correctly for LT, not just using the approximation. So to do that, what are we going to do is we start with equal to, and then we have our alpha, which is our parameter, and we fix it. Okay, we fix it, and then we multiply alpha with YT, so that is the real value of that period. We divide it by ST minus M, so it will be the seasonal, so we divide it actually, so we divide it with seasonal component of previous year same time, so that would be February. Okay, and then we close it, and then we put a plus, and then we use 1 minus alpha. We put this one here, put F4 to fix the value of alpha, and then we multiply this with LT minus 1. So LT minus 1 is this one plus TT minus 1, which is this one. Okay, and then we close it. So now we have our value ready here for the LT part. And now we have to just put in this one more equation, that TT. Okay, and then we are ready to go. So we start again with the function, and then now we will be using the beta value, and then we press F4 to fix it, and then we multiply this with LT. LT is this one, the same level. So LT is this one minus LT minus 1, which is the previous one. Okay, we close the bracket, we start with the plus, then again 1 minus beta, and we press F4 to fix the beta value. We close the bracket, and then we multiply with T minus 1, that is here, and then we close it. So just to double check if the equation is correct, so we have the beta and we fix it, multiplied with LT minus, so LT is this one minus LT minus 1 is this one. Okay, K18 and 19, yeah, and plus 1 minus beta multiplied with T minus 1, enter. So these values should be correct, and now I will just double click to have all the values there. And actually I will just go down and I'll make it up to 3 digit so it looks nicer. So that's our forecast actually. So now one more thing is that again for the outsample period we will not have this data. That would mean that we will not actually have this data as well, because this data, when we are calculating LT and TT in this level, we are already using this information. So we will not actually have this data available with us. So now without having those data available, we could forecast up to this point and that worked fine. But what about the next period? So now what are we going to do is we are going to use these two information that we had for the last period, and then we'll be using this part of the equation where we can use H to multiply with the trend value, okay, to get the forecast value. And for H, I'm going to use some values here, 1, 2, 3, 4, 5, 6. They simply refer to outsample forecast horizon, and I will make them something that we cannot see. So yeah, something like this, okay. So now for the forecast here, what I will do is I will actually use this one. I will yeah, let's say I just remove the equation from here. So I will use LT and I fix it, F4. So I fix the value of LT. LT plus we will have the forecast horizon multiplied with the trend value, and I fix it again because this is the last trend that I could have. And then I close my bracket and my another bracket, and then I multiply with its corresponding seasonal value, and that would be August of last year. Okay, so where do we have it? We have it here. So I'm going to select this one, enter. And then I'm just going to scroll it down. And just to double check, it works fine. Yeah, I'm in December. I'm using season of December and these two values. So it works pretty good now. So now we should calculate the error. Error of Holt-Winters. And we will again do the MAP calculation as we were doing before. So to do that, I'm just going to do this first part here. So we will start with the absolute. And this is my real value minus my forecasted value, right, divided by my real value. And this is the value I get. I just double click and I'm going to use only 3 periods, yeah, 3 decimal points, up to 3 decimal points. Okay, and then I'm actually going to drag these equations from there. Of course I have to remove all these parts because this only relates to the error part. So again, if you look here, you will see that we just have the average of the error part, percentage error part. So I will start from this point here. So I should not consider really the cells where I don't have any value. and then enter. Didn't really do anything, and I will just do the same thing here, just reduce the starting point of the cells, and yeah, it remains the same. And this part is only, yeah, this part it is fine. Here we have the differences, the error, yeah, and here we can see the performance. So actually we see Holt-Winters model is doing pretty okay, not too bad actually. But now what we can do is, so I just put these values as a starting point, but what we can do is we can try to optimize them. And to do that, we'll again go to data and we will go to solver. Now our goal is to minimize this value here, right? And by changing values, which values? By changing this value, and this value, okay? By changing these values, we want to minimize this. I'm going with non-linear. Let's see what happens. Solve, and okay. So now what I get is that, yeah, it's suggesting that we use 0.602 here and 0.64 here. And then we will get a value of 9.619. This one is not really good. If we consider only training sample, then still actually our knife forecast model is better. But otherwise you can see that actually our overall MAP actually improves with the Holt-Winters method, and also our test sample performance improves quite a lot. So by this way, I believe you can simply, by changing the three things in the equations of the multiplicative model, you can easily do the additive model, right? And in the next video, we'll cover multiple regression for forecasting.